Chemical symbols, formulas, and compounds. In this lesson, we're talking about symbols, element names, counting atoms, naming compounds, combining capacity, building a molecule, criss-cross rule, and naming compounds. Symbols. From your work with the periodic table, you know that each element is represented by a symbol made up of 1, 2, or 3 letters. So for instance, oxygen is O, sodium is Na. This is the case all around the world. And you can see we have different periodic tables from different locations. Now, although your periodic table will look slightly different depending on where you are in the world, it'll generally look similar. Element names. Many element names are Latin. So for example, silver is Ag because the Latin name for silver is argentium. Lead is Pb because the Latin name for lead is plumbum. Depending on when the element was found and when it was placed on the periodic table, that'll define what its name was. Just as single elements are used to represent single elements, these symbols can also be combined to form compounds. Counting atoms and compounds. There are over 118 known elements. These elements can be combined in many different ways to make different compounds. So for instance, carbon dioxide is CO2. It's composed of carbon and oxygen atoms. We use subscripts, that's this guy on the bottom here, in a chemical formula to show how many atoms are in a compound. So for example, CO2 is 1 carbon, because there's a 1 here, we just don't show the 1, and 2 oxygen atoms, and we show the 2 right there. So it's always going to be the one to the right of the element that we're talking about. So another example is water. In this compound, there are 2 hydrogen atoms, that's represented by the subscript 2, and 1 oxygen atom. Again, there'd be a 1 here, except we never write the 1, so it just writes as H2O. Now we never write H2O. That is completely wrong. That 2 always goes on the bottom, like we have on the left here. Counting atoms. Each symbol represents an element. So for example, NaCl is Na for sodium, Cl for chlorine. If only 1 atom is present, there are no subscripts. So for example, H2O, there's only 1 oxygen. The number in front of the compound is called the coefficient. The coefficient tells us how many of that compound there is. So if you have 2 H2O, that means you have 1 H2O, like we have here, and another H2O here. So there are 2 H2O molecules. Now, how do you know when one atom ends and the next begins? You're always going to have a capital letter followed by a lowercase letter, or no letter at all. So for instance, oxygen only is an O, but chlorine is a capital C and a lowercase l. Sodium is an uppercase N and a lowercase a. If you have C big O, that's carbon monoxide, carbon and oxygen. And if you have C little o, that's cobalt. So this is 1 element, this is 2 elements. Counting atoms. So if you have 2 H2O, normally we would say that there are 2 hydrogens and 1 oxygen. That would be in 1 water molecule. However, since there's a 2 in front, the correct answer is 2 hydrogen and 1 oxygen plus 2 hydrogen and 1 oxygen, which we can see here, right? 2 hydrogen, 1 oxygen, 2 hydrogen, 1 oxygen. So in total, we have 4 hydrogens, 2 oxygens, or 6 atoms in total. So what I'd like you to do is pause the video and complete Counting Atoms worksheet. Naming compounds. Combining capacity. Before we can write the chemical formula for a compound, we need to know how the atoms will combine with each other. Atoms can make a specific number of connections, bonds, with other atoms. The number of connections that an atom can make is called the combining capacity. When atoms combine, they form a bond. In this case, we have a bond here and a bond here. This is an example of carbon dioxide. That's the carbon, that's the oxygen, and that's the other oxygen. The combining capacity of hydrogen is 1. That means it can make 1 bond. The combining capacity of oxygen is 2. That means that oxygen can make 2 bonds. When putting these atoms together, we simply switch the numbers and write them as subscripts on the other element. Note the 1s are not included, and that's shown here. Hydrogen can make 1 bond, oxygen can make 2 bonds. Each atom involved in making the molecule are now happy because they have made the correct number of connections. They've filled their combining capacities. A diagram like the one above is called a structural diagram. This guy right here is a structural diagram, with these guys here being the bonds. Building a molecule. The combining capacity of calcium is 2. This means that calcium can make 2 bonds. The combining capacity of chlorine is 1. That means that chlorine can make 1 bond. So as I said before, what we're going to need to do is we're going to switch them. So the 2 from the calcium is going to be the subscript on the chlorine. So it's going to be right there. And the 1 from the chlorine is going to be the subscript on the calcium. And they're going to put them together. And you get Ca1Cl2. But what's wrong with this? We never write our formulas like that. We never include the 1s. Therefore, the correct answer is CaCl2. More examples. Silver and bromine each have a combining capacity of 1. Calcium iodine, calcium has 2 and iodine has 1. So I'd like you to pause the video and write the formulas for these 2 compounds. So since silver and bromine both have 1, we put a 1 down in each one. We know to get rid of the 1s, so our final answer is going to be AgBr. For calcium and iodine, we're going to move the 2 from the calcium and put it here by the iodine. We're going to take the 1 from the iodine and put it here by the calcium. Now we're going to be left with CaI2. Note that this I right here is an uppercase I, the criss-cross rule. Now, the criss-cross rule makes this whole process much easier. So what we're going to do, for aluminum chloride, we're going to write out the names with spaces. So we're going to write aluminum and chloride. Aluminum is represented by Al, chloride by Cl. We're going to write the symbols and the combining capacities above. Now you're going to need to be told what these combining capacities are. Aluminum is 3, chloride is 1. When we switch them then, the 1 from chloride comes down here to 1, and the 3 from aluminum goes here down here by the Cl. Now keep in mind, chloride is going to be the form for this compound for chlorine. Once we cross them over, we rewrite and say AlCl3. Check your understanding. Aluminum makes 3 bonds, and oxide makes 2 bonds. Oxide, remember, is going to be for oxygen, but we're going to call it oxide in this formula. So what I'd like you to do is pause the video and do the Criss-cross rule for aluminum with a combining capacity of 3 and oxygen with a combining capacity of 2. So we're going to write our symbols, Al for aluminum, O for oxygen. We're told aluminum has 3, so we're going to put a 3 up there, and oxygen is 2. We're then going to cross them over. We're going to rewrite as Al2O3, and we're done. Naming compounds, rules. Now for these, we're going to be talking about a special kind of compound called ionic compounds. There are other kind of compounds, but for this, we're going to talk about ionic compounds only. So in ionic compounds, the first rule is that metals are going to combine with our nonmetals. How do we know which ones are which? Well, number 2 rule says that metals are going to be on the left, and the nonmetals are going to be on the right of the periodic table. Number 3, we're going to write the name of the metal first, then the nonmetal. And number 4, we're going to change the ending of the nonmetal to "ide." That's why oxygen became oxide. Check your understanding. Aluminum, metal, with oxygen, nonmetal. And we have chlorine and magnesium. For the first one, is given to you. For the second one, you need to find out whether chlorine or magnesium is the metal and which is going to be the nonmetal. Once you've done that, you need to name them. So I'd like you to pause the video and name these 2 compounds. So for the first one, it's simply going to be aluminum, because we're told it's the metal, oxide, because we changed the ending from oxygen to oxide. Now magnesium is going to be the metal, and chlorine is the nonmetal. We can see that on our periodic table. Remember I said that metals are going to be on the left and nonmetals are going to be on the right-hand side? Well, chlorine is right over here, and magnesium is over here. So magnesium is to the left on the periodic table, so magnesium is going to be the metal, and chlorine is going to be the nonmetal. So when we write the name for this, we're going to write magnesium, then we're going to change the ending of chlorine to chloride, and we're done. Check your understanding. I'd like you to write the name for the following 6 compounds. Okay, got your answers? Let's check them out. So for the first one, Ba is barium. O is going to be for oxygen, so we change that to oxide, so we get barium oxide. Sodium bromide. Magnesium iodide. Strontium fluoride. Potassium chloride. Cesium fluoride. So see how we did there, right? You're going to change the ending of the second to "ide," and that's what we did here. Iodide, fluoride, chloride, fluoride. Now, a lot of students get a little concerned here because they think, well, what am I going to do with the ending? How am I going to know where that "ide" goes? And it's going to be the one that makes more sense. It's not going to be fluorine-ide. It's not going to be chlorine-ide or chlorine-ide. That doesn't make as much sense. So if you just say it out loud, it'll be the one that sounds the best. And that concludes our lesson on chemical symbols, formulas, and compounds.